Who does not have a calculator? Okay, do we all have a calculator? Who doesn't have one? I will lend you one of mine. Okay, walk it up. Come on. Come on down for a calculator. You will need one for sure today. Last call on calculator. You're welcome. Going once. Going twice. Perfect. So if you have to guess, applications means what, guys? Applications of logs and exponential. What are we about to study? Word problems. You're right, y'all. Okay. All right. Let me erase this really quickly. This is our last skill, by the way, of Unit 6. We have 4 boxes on here. So the first box where it said standard appreciation, you read me the entire box, please, Amina.
A is the final amount we should
Well, read the equation first.
Okay. A equals
B times?
B times 1 plus 4 to
1 plus R.
1 plus R. Why did I say 4? I'm sorry.
That's okay.
To the T. Oh my god.
Oh my god.
Okay, now read the bottom.
Okay. A is the final amount, P is the initial value, R is the rate, and T is the time, generally in years.
Perfect. So when we are talking about an object or an investment that's appreciating, what are we talking about?
Something gaining value.
Yeah, something gaining value. Okay, so in real life, give me an example of something that's gaining values over time.
Bitcoin.
Matt.
The love of my child.
You have a child? That's scary, Matt. Okay.
Zero right now because I don't have one.
Normally, I would agree. I have the love of my children. Okay. What else that's gaining value over time?
Money.
Yeah. What about money?
Like,
What do you have to do for it to gain value over time?
My money went.
Huh?
No, it's fake.
Okay, let me ask you this question. Let's say you have $1,000. You put it in your shoebox. You put it in your bed over 10 years. Is that money going to gain value over time?
no.
Why not?
Unless it's a $2 bill.
Because you haven't done anything to like add to it within those 10 years.
But are you even is the money value the same over 10 years? If you are not doing anything with it, all you do is put it on your bed. No, what's happening? It's what? Why? Thank you. Okay. If you don't invest your money, normally investment obviously there's a risk, but if you don't invest your money, okay, and just kind of, as you can hear, shoebox on your bed, it's gonna lose money over time if you don't do anything with it because of inflation rate. Okay. Appreciation is, we're talking about money investing normally. Sometimes you can lose. What else in real life that will gain over time?
My weight.
Some bank accounts, like.
So again, investing.
Yeah.
Okay.
Your house.
Your house normally, right?
Yeah.
We're talking about normally. Your house will go up in value over time. Some people love to collect plastic things like cars, right? So some cars will appreciate over time. Would you guys agree?
Yeah.
Your normal daily driving car will do what?
It's gonna go down.
These are gonna go down, but some classic cars will go up. Like coins, I know some people collect coins, those will go up. Baseball cards, I've heard of that. So those things will go up, okay? Next, standard depreciation. Jason, help me read that following box.
A is the final amount. P is
Wait, we're reading the equation.
A equals P times 1 minus R to the power of T. A is the final amount. P is the initial value. R is the rate. And T is the time, generally in years.
Perfect. Now let's compare these two answers for me. What's the only difference between these two answers? I mean, two equations. Yeah, adding and subtraction. Now, if it's appreciation, then what's your rate? Positive or negative? Positive. If it's depreciation, that means your rate is negative. So that's why you see a 1 plus a negative rate right there, or 1 minus R. Now over here, some fancy thing going on. Appreciation compounded in intervals. Maurice, read me that whole first box right there on the top.
A is the final.
No, equation.
Oh, A equals P
Times?
times 1 plus R by N
To the power of?
to the power of
NT. Okay,
N.
now,
T.
good. A is? Now do be the bottom.
Oh. A is the final amount, P is the initial amount, R is the rate, N is the number of intervals, and T is the time in years.
Perfect. Would you agree that all of the variables have the same meaning? The one new variable is what? What's the one new variable in this equation? N, okay? As you can see, this one has N here in the denominator, and then also a little bit on the exponents. It says N is the number of intervals. Anybody know what that means in this equation? Number of times it happens per year. So if I said daily, okay, that means N is how many times per year? 365. If I said monthly, that would be 12. So when you're using, N is 12. So when you're using these equations, make sure you understand the language. If I said compounded quarterly, that means N is 4. How about new word, semi-annually? 2. Okay, so N is 2. Those are a very common N that you're going to use. Semi-annual. Semi means what? 2. Annually means? Yearly. So semi cut in half.
Wait, if it's semi cut in half, doesn't that make 1?
Right, but there's 2 halves in a year. So we're talking about per year. How many times per year? You're right. Okay. Last set of definitions here. Quinn, can you help me read?
A equals P times E to the on T. A is the final amount, P is the initial amount, R is the rate, and T is the time of years.
Perfect. So as you can see, A, P, R, and T are the same exact definitions. Well, is E a variable? No. What's E?
It's a number.
Yeah, what they said.
Right. Just like, remember how I asked you, hey, make sure you know E, just like you know pi. E is 2.7183, right?
Wait, are there variables that are E?
We don't normally use E as a variable.
Because it's a number?
Because it's a number. Just like we would never use pi as a variable, because it's a number. We've already used those for numbers. Okay? Usually just E and pi right now. Okay. Number 1, can you help me read, Valerie? Okay, a piece of office equipment valued as $25,000 depreciates at a steady rate of 10% annually. All right, class. Part A. Lewis, let me read part A. Part A.
Create an equation VT to represent the value of the office equipment after 2 years.
Perfect. We're about to write an equation. Out of the 4 equations that you were just introduced, which one? Standard depreciation. So here we go. Let's write that out. A equals P times 1 plus or minus?
Wait, is that an L or a 1?
Plus or minus? Minus R to the what? T. Perfect. Okay. Look at your notes. Okay. Shh. Remember, and they don't want you to use A or P. They want you to use V of T. It says, give me a V of T that we can use later, okay, to calculate your depreciation rate I mean a value. Do we know what R is?
No.
R is what?
Wait,
10%. Do we plug 10% directly in?
No.
No. Convert it to decimal. How do we move it? To the right or to the left?
10.
0.10 or 0.1. That's a personal choice.
Is it 2 to the left?
Okay, 2 to the left. Next, we need to plug in some other values. Do we know, by the way, what's A and what's P?
A is VT.
A is
The value.
the value of when? Beginning or the end? N. P is
The beginning
the
value.
beginning, initial value. Do we know A or P? Either
No,
one?
P.
P. What's P in this case?
25.
25,000. Okay, 1, 2, 3, 0. Minus rate. What should we enter in for rate, Matt? 0.1. Perfect. To the T power equal to, they don't want you use A, they want you to use V of T. Now, one takeaway, 0.1 Keely, what do you think that is? Perfect. 25,000 times 0.9 or 0.9 to the T power. Can I take 0.9 and multiply that to 25,000?
No.
No. So guess what? That is the end of your work. Okay. Box it up. That, no, that's not the egg roll. That's the end of your equation. Thank you very much. Okay.
Got the egg part
Whew. Okay. Over.
Oh, dude, it just keeps going.
It keeps going. All right. Jasmine, can you read me part B?
How much will it be worth after?
Oh, then.
Okay. How much will it be worth after 5 years? Are you looking for time or money?
Time is
Money.
Money. All right. You already have the equation. What is our T? 5. So we're looking for V of how many years? 5 years equals, what do we write down on the right? 25,000 times 0.9 to the what? Great. Bust out your calculator. What do you do first? Do you do 25,000 times 0.9 first? No, that will be incorrect. You want to do exponent first, then multiplication. Once you are done, I want you to show a partner or multiple partner, whoever you sit next to, your calculator, to see if your digits are correct. If you're looking for money, what should you be rounding to?
The dollars.
Not dollars, but hundreds, right? Okay, to the nearest 2 decimal places. Skylar, give it to me.
The final is VT equals 14,762.
762,
Dollars and 25 cents.
25 cents. Confirm or deny?
Confirm.
Confirm. Thank you.
Would it be V of T or V of 5?
V of 5, because that means after 5 years, this is how much it's going to be now. Hey. Shh. Excuse me. Don't turn around, please. Okay. Chloe, can you help me with number 5, please? I mean, number 5, letter C, please.
In how many years will it be worth $5,000?
Alan, you have your hands up, hon.
Oh, let's say you have like 100 cents or 0.100. Would you just add that to the dollars?
If you have 100 pennies, yes, you need to put that towards $1.
So you would have, okay, it's like 154. You'd write.
If you have
You
100,
rounded, you just add the 100 to the.
there's no way that you would have 154 to begin with. Because it's already starting out in whole dollars. Does that make sense? Because it's not saying in pennies. You know what I'm talking about? Okay. What are we looking for on C? Wyatt's missing. So Bella, what are we looking for on C?
And how many years will it be worth $5,000?
We're looking for time, money. What are we looking for?
How many years?
Time. All right. What do we do with the 5,000?
We put it in for V.
V. That's right. 5,000 equals 25,000. What variable are we solving for?
T.
T. Beautiful. Here we go.
Step number 1 in solving for t. Dominic, what do you want to do?
Good. Take your calculator, divide both sides by 25,000. Now, there's also a mode in your calculator that I want you to learn. Once you take 5,000 divided by 25,000, I want you to find the button that says math. Can you locate the button that says math for me on your TI? And go to fraction and hit enter. Okay. All right.
1/5.
And here's the reason why I want you to convert your decimal into fractions. Are you boys ready?
Because it's more precise. 1/5.
Okay. Once you take 5,000 divided by 25,000, find the button math.
You guys are so loud.
Oh wait, you guys, on tabs. Remember, I do not want you to round until the very, very end. That's why I'm teaching you a new button on your TI. Whatever decimals you have, hit math for me and hit fractions. It will turn it into your fractions. So that way we keep on using the fractions until the very last step, and that's when you can round. Jason, what's up?
Is it a second button?
No, just math. Just hit math. So do me a favor, and then hit fraction, you see it? And enter, and then enter again. It will give you a fraction. What fraction do you see?
1/5. Perfect. Okay. So divide both sides by 25,000. Okay. Now, we are still solving for what again? T. How do we solve for time from here? Math. That's right. You're going to hit it with a
Log.
natural log or just log?
Just log.
Just log. Log base what?
Log base 1/5.
Log. Thank you. Log base 0.9 of what? Of 1/5 equal to t. What's your next step in solving for t? What do you do here? What do we do here? Alisa? The change of base, you're right. Log of what divided by log of what? Log of 1/5 divided by log of 0.9. Now this is the step that you may round. I want you to round to 2 decimal places, please. Whenever you're ready, punch it in, show your partner your calculation, and then I'm going to call on one of us. Write it in your notes, box it up. 2 decimal places will be wonderful. All right, Josh, what do you have, hon? 15.28. All right, Kelly, what's the unit of measurement? Which one? Thank you so much. Okay. Class, in an application, you have to give me the correct unit of measurement. Okay. Number 2, help me read. Alicia.
In 2009, there were 150 Iberian lakes in the world. In 2010, there were 120. If the trend continues and the population decreases exponentially.
Thank you very much. Letter A. Can you help me read? This one goes to Sam.
Create an equation to represent the number of Iberian lakes based on the number of years after 2009.
Perfect. Out of the 4 equations that you were introduced to earlier, which one? Is it appreciation? No. What is it? Depreciation. All right. The depreciation is A equals to P times 1 minus R to the power of T. Okay. Now, Sam said create an equation called L of T to represent the number of Iberian lengths based on the number of years after 2009. Now, if you need a visual aid, you can definitely make a table. The first year that they gave you was 2009. And how many were left in 2009?
150.
150. Then they give you 1 year later. What happened?
30. What we lost.
Yep. They said, okay, it is now 120. For us to write an equation in terms of t, we are going to eventually fill in everything except your t. Do we know the rate right now? Do we know the rate? No, but we can calculate it pretty easily. Over one period of 1 year, which is t equals to what? 1. What was the beginning value and an ending value?
120.
That's right. So 120 equals to 150 times 1 minus. We do not know the rate. Some of you actually do. But what's your t value here? 1. Well, anything to the power of 1 is just what? Itself, right? So from here, how do you solve for r?
150 on both 1 and 9.
Good. Divide both sides by 150. Take your calculator, give it to me as your reduced fractions really quickly. Ashley, whenever you're ready, give me that 120 divided by 150 as a fraction. Fraction, his math. Four-fifths, perfect. What do we now to solve r? Subtract 1 from both sides. So 4/5 minus 1 equals r. What's r coming out to be in fractions? I'm sorry, negative r still. Sorry, that's negative r equals that. So negative r is negative 1/5. Divide both sides by the negative 1. R is 1/5. That's your r. Now, if you were to put in decimal, what would that be? 0.2. Perfect. If you were to put in percentage, what would that be? 20%. Okay. Now, but mind you that part A said give me an equation in terms of LT. Okay. So L of T equals, you have to fill in the initial value that was starting with. What was the initial value? 150, bless you, times 1 minus, what's your rate? Point what? 0.2 to the t power. What's 1 minus 0.2? 0.8. So this is the equation right here. Okay, that will give us our depreciation over time. Part B, can you help me read part B, please? This one goes to Amina. All right. How many? How do we calculate that? Do we plug in 2020 for time? No. What do we plug in? How many years, right? If 2009 was the first year that you know of, how many years since 2009 is that? 11 years. So what you want to do is T is 2020, take away 2009, which is 11 years. I wish I have an equation to plug it in.
You do.
I do. Okay. L of what? Oh, can you give me the bubble, Chloe? Thank you. L of 11 equals 150 times 0.8 to the power of 11. Do we round it to decimal place still? No. Okay, round it. Use the proper math rounding rule. So whole what? Whole number. And write in the appropriate units of measurement. Bust out your calculator, punch it in. Do we punch in 150 times 0.8 first? No. Make sure you do not do that. Once you have an answer, can you show your partner the calculator? Make sure you round it correctly, please. Okay, Stacy, whenever you're ready, give me the final answer. Could I keep that as my final answer? No. What should we round to?
Whole number.
So what is it, Stacey? About 13. What's the unit of measurement? What is it, Stacey? Dogs, cats, rivers, boats? What kind?
Oh.
Yes.
It can't be 13.
It can't be 13.
You can't round up.
Yeah.
Because
You have to round down.
have more.
Yeah, that was a debate earlier with my other classes as well. They said, oh, how should we round the answer to offset?
12 voices and then like one really starting
Some classes, like I think if you're in like science classes, they tell you, oh, you know what? Always round down, like with human and whatnot. In here, I'm not very strict in terms of how you round that. I'm just going to use a normal math rounding rule. So obviously, this is also using the wavy grid. This is about, right? About. So if you write to 12.88 and you decided to round it down to 12, as long as you have the decimal in there, I'm going to be okay with that. So, like I said, I'm just going to use math rounding rule. So that's why I said about. So it's not an exact number. Example 3, Kylie, help me read, please.
Someone is depositing money into a CD that is compounded continuously at 6.2%.
Beautiful, nicely. What's the key words in that first sentence?
Compounded continuously.
Yes, compounded continuously. Out of the 4 equations, Alan, what do you think we're going to use? Compound one. Compound what? In intervals?
No.
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 Which one?
Standard appreciation.
Standard appreciation?
Appreciation compound.
Uh-huh. So, which one? Okay. Guys? Jenny, help him out.
Oh, all right.
You got it. Okay. Alan, what is it?
Appreciation compounding continuous.
What key words in that first sentence allow you to use that one?
Compounding continuous.
That's right. All right, here we go. A equals P times number E to the power of R times T. Part A. Delaney, help me read part A.
Create an equation to represent the amount of money in the account after 2 years.
Thank you very much. Okay. Do we know the interest rate? It's 6.2%, but you can't use that in your equation. You have to convert that to 0.062. Beautiful. As you can see, they never gave you the beginning investment amount, and they never told you the ending investment amount. But they do want you to write an equation A of T. So that's what we are going to start. A of T equals, since we don't know what P is, really, we're going to keep P as P, which is the initial investment amount. E, is that a variable? No, it is a number. Your interest rate is converted to decimal, 0.062, and then T, we're going to leave it as T. So that is our equation for example 3. Part B, Billy, read me part B.
This model helps you to calculate the nearest hundred every year.
Okay. What does it mean for her money to double?
The amount of money is 2 times.
Right, but it never gave us the initial investment before. So what are you going to do?
We have to find the amount of years it takes for the compounding continuously in equal from 6.2% to 100%. Or 200%.
I think that this one really says for her money to double, not the interest rate. I think.
Well, no, but like the interest rate over time, the amount of money that goes into it because of the interest rate would equal up to 100%. That's the original.
Right, so whatever she invested in, she wants twice as much.
Yeah.
Okay, but they never gave you, right, in this problem, they never tell you how much she started out with.
You don't need that because the interest rate doesn't specify how much money there's in it. It just specifies the percentage of whatever money that is.
Okay, so let me ask you, if it doesn't tell you what P is, what do you want to start with? Can you make up any number you want?
Yeah.
You can leave it a P. That means you end up with how many P's? 2 P's, you're right, okay? So, and guys, that's absolutely true. Since it doesn't tell you, you can totally leave it as P. If you start out with a P amount, you can end up with how many P's? 2. That's doubling, okay? Times E to the 0.062. And then we're going to keep T as T. Next step, what do you want to do now, Jonah? How do we solve for T? How long?
Wait, how to solve for T?
Yeah.
No. I don't know.
That's totally confusing, right? What if I want to start out with $100? Then what would she earn if she wants to double it? 200. Then we just have to solve a T. Well, 100 is still kind of hard. What if I want, what's the easiest number you start out with? Thank you. Let's start with $1 US. Okay, no. $1 US investment. That means you're going to end up with what? $2 US times E to the power of 0.062 times T. Now, Jonah, how do you solve for T from here?
Yeah, divide by 1.
Divide by 1. Guys, anything by 1 is still? Still itself. So 2 equals E to the 0.062 times T. What's next? Rewrite it how? ln. How do you know it's ln instead of normal log?
Because there's E.
There's E. Okay. Okay. A couple ways you can do this. You can start out writing log base what? Log base E over 2 equals 0.062 times T. You can never ever leave log base E. What do you change that to? Natural log of 2 equals 0.062 T. Some of you can start out writing natural log of 2 right away. That's totally okay. Then from here, to solve for T, what are you going to, Danny? Divide both sides by? Good. So T equals natural log of 2 divided by 0.062. Use your calculator. It says round to the nearest 2 decimal places. Let me know when you have your decimal. Kelly, let me know when you're ready. $11.18. Confirm, deny?
Confirm.
Unit of measurement, guys? Years. Okay. Years. I will tell you when it is. Okay. I'm just going to go right through lunch if this is the rate we're going. Number 4. Saxon, help me read number 4, please.
Dave bought a new car 8 years ago for $5,400. To buy a new car comparably equipped now costs $12,500.
Thank you very much. So if we just got done reading the facts, is this car depreciating or appreciating? It is. It is appreciating. So based on that, Claire, what equation are we going to use? Claire?
A
A equals P times 1 plus R and parentheses to the T power.
Great. Part A. Help me, Max. Read part A. Perfect. Thank you very much. So for this question, what is the p-value that we would need to use? Killy. Perfect. 5,400. What is our a value? Jasmine. Mm-hmm. $12. Perfect. Nicely done. Equals 1 plus. Do we know, Skylar, a rate of inflation right now? No. We are going to leave it as is. Do we know time, Chloe? 8 years. Perfect. Take your calculator. Guess what you're about to do?
Divide by 5,400.
Good. Take your calculator. Divide both sides by 5,400. Do I want you to round at this time? No. Give it to me as a fraction, Bella, whenever you're ready. Thank you very much. Equals quantity 1 plus r to the 8th power. Mind you that you're solving for the variable r, which is the rate. How do we solve for rate?
Exponent.
Exponent, what do you mean by that?
Or would you turn it into exponential?
It's already some sort of a power. How would you turn that into log? What would be your base?
1 plus r.
Would you be able to solve log base r? No. So let me ask you this. If this instead of an 8 power and it said that's a square power, what would you do? Square root. If that's a 3rd power, what would you do? Cube root. Well, it's an 8 power. 8 root it. Okay? So octave root it. Now, 8th root class, there's no button for 8th root. But guys, 8th root, the 3rd root, square root, if I were to write it as a fraction, what would that be?
-8.
Nope. What fraction? 1/8. Okay. Okay. Now take your calculator. Whatever answers you had before, raise it to the power 1 divided by 8. That means there's a caret on your calculator. Anybody who can find the caret?
Yeah.
Make sure you put parentheses around the base, which is 125 divided by 54, and another set of parentheses around the 1/8. So once you have it, give it to me all decimals, okay? Not just a little bit. Show it to your friends first before you're called upon. Remember, I don't want you to round until the very end. So right now, I want you to give it to me as all decimals. Then I want you to move the 1 over. Once you move the 1 over, then you can round the rate at the very end.
-0.11.
Oh, I'm so sorry.
And don't forget, you need to have a set of parentheses for the base, which is 125 divided by 54, and another set for the power. Okay. Alan, 125 divided by 54 to the power 1/8. Give it to me. It's all decimals. 549 equals to 1 plus r. Someone confirm that value for me.
Yes.
Okay. I'm going to solve for r. So now we are going to subtract both sides by? Oh no. So 0.11067549. That's 175? What?
What?
Oh, thank you. Good eye, Rex. Well, that's a decimal, and if you're looking for rate, most likely we would be using percentage. So how do you move it so you can have percentage? Move it 2 spots, right? So about 11.06%. Stacy, help me read part B. Perfect. So now it's asking us to find C of t, which is an equation. We already know the beginning value, which was 5,400. We found the rate, which is 0.1106. And then remember, based on C of t, so we want to leave t as t. And then we have to simplify this equation out to C of t equals, what's 1 plus 0.1106? It's 1.1106 to the power of t. So this one is the equation. Jonah, you have your hands up.
Why is it not 11.06?
11.06, hon? What is it?
Because like it's 11.06 percentage.
Right, but when you put it in, you have to convert to decimal so you can add it. Can you help me read part C, please, Jason?
How many years after Dave bought his car would the car be comparably equipped? $20,000.
Where would you substitute $20,000, Jason?
The cost of the car.
Yeah, so the ending value, right?
100.
Okay. Guys, would that be the ending value?
Yes.
Perfect. We're looking for what? Money or time?
Time.
Okay. All right. What do you compute first, Kylie? Good. Take your calculator, Kylie, divide by that, give it to me in fraction, because I don't want to round until the very, very, very end. Someone confirm? What is it? What is it? 27. Thank you. Equals 1.1106 to the t power. Currently, it's in exponential form. How do we solve an exponential form?
Natural log.
Is it natural log?
No.
No, regular log. Log base what? 1.1106 of what? 100 over 27 equals to t. How would you use your calculator to solve for t? What do? Change of base. T equals log of what? 100 over 27. All of that is divided by log of 1.110. Rounded to approximately 2 decimal places for me. Let me shuffle your cards. Don't forget the correct unit of measurement, which is what, by the way? Years. All right. Louis, whenever you're ready.
I got 12.4.
12.48. Unit of measurement, Louis? Someone confirm, deny?
Confirmers.
Confirmer. That is now officially